So today we are going to solve the last problem of Leetcode Weekly Contest 284, which is minimum weighted subgraph with the required paths. So we are given a directed weighted graph, and we are given three indices, three vertices of the graph: source one, source two, and destination. So we have to find the minimum weight subgraph, in which we can go to destination from both source one and source two. So you can take this example like the blue edges represent the optimal subgraph with minimum weight, and so so first we have to make some observations. So let us try out to make some observations. So this is the given graph. So here you can see is that what is the first observation? Let us figure out. So a first observation which I have made is that there is no loop in the resultant subgraph. So there should not be any loop. I guess this is the first observation you can make. There should not be a loop. So why is this observation? So if there is some loop, let's say there is a loop 1 to 2, and then to 3, then to 4, and then to 1. So if that is a loop, that means 1 is our uh, destination vertex. So we can easily remove this edge. We can remove this edge. Why 1 is the destination vertex? Because don't need to put any edge, like incoming edge in any vertex besides that, destination vertex. So if 1 is not destination vertex, we can remove this edge. If 1 is destination vertex, then we can remove this edge. Okay, so that's why we can't have any loop in the graph. Okay, so let us figure out how we can solve the problem now. After that observation is made, then what will be the second observation? The second observation could be that there could be some common path. There could be some common path between source 1 to destination, between the path from source 1 to destination and source 2 to destination. So let's say, um, here what is the common path? The common path is 1 to 5 and then 5 to 1. So this is the common path. This is the common path. So and the extra path is added here is 2 plus 1. Okay, you can clearly see that. So there should be some common path and there should be some extra path. Okay, so what observation could we make from this point? So the extra path, it is not necessary that extra path is covered by both source 1 and source 2. It could happen that source 1 go to source 2, source 1 go to source 2, and source 2 go to destination. This could be one thing. Okay, this could be one thing, and this is the extra path. Okay, this is the first case: source 1, source 2, and destination. This is the common path. Okay, this is the first case. And in the second case, what could happen? In the second case, it could happen like source 1, sorry, this is source 2, then source 2 go to source 1, and source 1 go to destination. This could be the second way out. So now this is the common path, and this is extra. There could be another third way also, where source 1 and source 2 go to some common vertex, let's say C. So source 1 go to common vertex C, and source 2 also go to common vertex C, and C goes to our destination vertex. This could be another way out. So this is the common path, and this is extra 1, and this is extra 2. So our answer will be 1 plus E2 plus common. So what is the observation we can make is that here, let's say in the first case, this is the first case, this is the second case, and this is the third case. So what is the observation can we make? The observation we make is that in the first case, case 1, the C is source 2 here. C is source 2 here. And in the case 2, C is source 1. Okay. So 1 and 2 is the sub part of case 3. So what we can figure out is that we have to go to any vertex, common vertex C, from both source 1 and from source 2, and we have to reach destination from C. So if we take the smallest distance from source 1 to C here, which is E1, and smallest distance from source 2 to C, which is E2, and the common distance from C to destination, which is common. Okay, so we have to find this minimum distance from source 1 to C, and minimum distance from source 2 to C, and minimum distance from destination to C to destination, right? So we have to find these three minimum distances, and if we add them up, then we'll get our desired answer. So you can see that the constants are low, so we can do order of n. This is not low constants, but we can do order of n, so we can iterate over all C. So our C could be any vertex from 0 to n minus 1. So if we iterate any distance from 0 to n minus 1, and our first distance will be distance from source 1 to C, from distance from source 1 to C, and second distance will be from second distance will be distance source 2 to C, and our third will be like what will be our third will be like distance from C to destination. So we have to figure out this three distance, and the answer will be minimum of all this like this one plus this two plus this three for all the values of C. So let us check our code. I think you will easily understand my code. So here is my code. So here you can see that I have constructed one this is a forward graph, and this is a backward graph. Okay, so I have constructed the forward graph this way and backward graph this way. So why I am doing that is that first we will try to figure out what is the minimum distance from 5, like minimum distance from destination to all other vertices, which will be stored in this in my code. So this will store all the distance minimum distances from any vertex to destination vertex, and this two will store any distance from our source 1 vertex to any other vertex, and these three will samely store as distance from any other source 2 to any other vertex. So what is this one? This one is the sorry, there is no this one. This is the distance from any node to destination. This 2 is the minimum distance from source 1 to any vertex. This 3 is the minimum distance from source 2 to any vertex. So if I find the sum of I, this C plus this 2C and this 3C, here I have done this. If we find for every vertex, we find the minimum distance from this I plus this 2I plus this 3I, which I have already mentioned why we are doing that, then we will get our desired answer. If our answer is greater than equal to infinity, you can see here answer could be 3 into infinity, then our answer will be minus 1. At the end we are returning the answer. I hope you have understood my explanation. If you have any doubt, you can ask in the comment section. Thank you. Please subscribe my channel.